Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so this question asks to draw the Lewis structure for the sulfur dioxide molecule. Be sure to include all resonance structures and that they satisfy the octet rule. You just okay. So the SO2 molecule, when we write the Lewis structure, we need to first find out the total valence electrons in the molecule. In the case of sulfur, there are 6 valence electrons. And in the case of oxygen, there are also 6 valence electrons. And since we have 2 oxygen atoms, there are 12. And then if we add them all up, then we get a total of 18 valence electrons. So we start off by writing the central atom, which is sulfur, and then we write the 2 terminal atoms on either side. So I'll just draw the oxygens on either side. And also recall that every bond contains 2 electrons that take part in the bonding. So far I've only drawn 4 valence electrons, and now I'm going to fill out the rest on as lone pairs on our terminal atoms. But before I finish writing out the oxygens, you'll notice that our sulfur doesn't have a full valence shell. So I'm going to draw a double bond. And let's count out to see how many electrons I've drawn so far. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I just need 2 more. And I'm going to put them on the sulfur, since sulfur doesn't have a valence octet or a full octet yet. And after doing that, it now has a positive charge. And this oxygen on the left has a negative charge. So this is one Lewis structure of SO2. And if we were to draw the resonance, another resonance structure of this molecule as well, we'll show this oxygen having the double bond instead, and the oxygen on the right to be single bonded. So again, it's just the same concept, but the oxygens have switched sides. Okay, so these are 2 resonance structures that satisfy the octet rule. So the junior tutor said to first determine the total number of valence electrons. The sulfur atom in group 16 has 6 valence electrons, and the oxygen atoms in group 16 have 6 valence electrons as well. for a total of 18 valence electrons. Second is to draw a plausible skeletal structure by joining atoms through single covalent bonds. Third, subtract 2 electrons for each bond in the skeletal structure. The 2 bonds in this structure account for 4 of the 18 valence electrons. This leaves 14 valence electrons to be assigned. Next is to complete the octets for the terminal oxygen atoms and assign the remaining valence electrons to the central sulfur atom. Okay, so they added all the lone pairs and notice that the central sulfur atom does not have a complete octet yet. So we assign multiple bonds between the sulfur and oxygen, forming 2 resonance structures. Yep, so this solution is correct. Not sure if the question asked to add formal charges, but yeah, I'll just add that for the resonance structures, the sulfur atom will have a positive charge and the oxygen, or the single bonded oxygen, will have a negative charge.